take 3. First 2 takes, it's just too slow. I've been trying for a really long time. Usually I like to show you how to actually sketch the videos. I've done that in a previous one using this insert drawing, and then you could just draw the curves. But we're going to have to cheat and use ones that I just made. Okay, but when you sketch it yourself, you could have more details. So we're going to do this problem, solving backwards. For a normal curve whose mean is 12 with a standard deviation of 3, find the x value with 80% of the data to the left of it. Sorry, as you can see, it's 5:20. I'm very, very tired. So I really need to go to sleep. But I think I could still do some 6 to 6 for you guys if my computer actually lets me. While the rainbow wheel is spinning, we could read it one more time, the problem. Alright, so what do we have? This is what I like to do, just step by step. The area, which is a left tail area, is 80%, 0.80. And the mu is 12. And standard deviation is 3. And I'm going to actually, just so it looks nice, put the symbols in. So the mean and standard deviation. There we go. Alright. So that's what we have, but we also need to draw the chart. So what I would do is have a straight line, draw a curve, right smack in the middle we have 12, right, because that's the mean. Since the standard deviation is 3, we'll have 12 right in the middle. Then when you have standard deviation moved over 1, so z equals 1, it would be at 15. And going 1 standard deviation below, 12 minus 3 is 9. And you could go even more below, so to 6 or 3. That's what's nice about sketching it by hand. But since I'm having trouble with my computer, I'm going to just use this graph, this chart that I made. And it's not as detailed, but it gives you the idea. Oops. Nothing works at 5 in the morning. Actually, let's just use this. Okay. So this is what we want, this top picture here. You could see 12 is right in the middle. And for our final answer, we're asked to figure out what x value is associated where 80% of the area is to the left. So when you're drawing, you put 12, like I was saying, you would have, if you're going down, 9, 6, the standard deviation is 3. You just guesstimate. So just looking at it, we know that our answer for x is going to be above 12, right? We know, I don't want to say, because we just know it's going to be above 12. Probably not going to be more than over 15, because that's already 1 standard deviation above. So let's see. So we have our chart. But before we could get to the x value, we need to go first to the z. So here, what I just drew again is what the problem is saying. And this is, let's see, this is a sketch where approximately 80% of the data is to the left. So what we do, because we have our chart, which is in the book, and I also posted it in the learning modules, the standard normal table, page 579 in the book, which is right here. So when we have the areas, we can figure out what z-score is attached to it. Going the normal way, we have z-scores and then we figure out the area, but this one, like I said, it's a backwards problem where we're given the percent first. So again, what we're finding right away is not the x, there's a step in between finding the z-scores. So we go from the percent, well, let's use the same font. Okay. So we go from the area under the curve. Wow, okay. Should not make videos this late. We go from the area under the curve to the z-score to the x value. That's why it's backwards. Usually, and we can also go from x value to z-score to area. Okay, so here is the same idea. You don't have to draw two of them. It's the same exact chart, but now we're getting the z-value. And we figure that out by looking to see, using the standard normal table backwards, you look up the z-value associated with 80% of the area. So where the left tail area is 80. So you do this while I try to make everything neat. And if you got a negative number, you know that the answer is wrong, right, for z. It looks like it should be close to 1, or definitely positive. So let's see. So 0.8, and I'm looking for positives. Let's see. Your eyes will probably find it faster than me. Here we go. So 0.7995 is the closest we have. So it matches up with z of 0.84. So z is 0.84. Okay, so far so good. We have z is 0.84. Now we're one step away from the x value. And you know the relationship. Right, we use the formula. And I'm gonna write it out neatly for you. So z equals x minus mu over the standard deviation. And then we plug in what we have. So you could start plugging in. Again, I just want everything to be nice and clear. We just figured out what the z-score is. It's 0.84. If you look to see what we had that the mean is 12 and the standard deviation is 3. So we're plugging that in carefully. And 3 here. Okay, and we solve for x. Come on, Rainbow Wheel. Okay. No. There we go. Whew. So now we solve for x, which you probably already did, because I'm having all these technical difficulties. So we multiply 3 on both sides. We have 0.84 times 3 equals x minus 12. Okay, and to get x by itself, we add 12 on both sides. So we multiply 0.84 times 3, and you could do this either in your head or using a calculator, and then add 12. Okay, so what's that? 14.52 equals x. Let's make sure, since now it's 5:30, I'm going to use my phone. Make sure I didn't make any math mistakes. Point 0.84 times 3 plus 12. Good. Can still do it. So let's see if our answer makes sense now. So for a normal curve whose mean is 12 with a standard deviation of 3, find the x value with 80% of the data to the left of it. So our answer of 14.52 makes sense using this chart. It helped us figure out that our answer is right. Good. And I would make it clear somehow that this is the answer. 14.52 is the x value associated with a normal curve whose mean is 12 with a standard deviation of 3, where there is 80% of the data to the left. Okay, that was really wordy and poorly worded, I might say, but I think for 5:30 I get full credit. Okay, hope this helped.